Now, good afternoon. Welcome to JCSF online tutorial class. So I am Mr. JS. So your physics tutorial master. Now, this afternoon, we want to round off with the topic that we have been dealing with for so long. So, which is work, energy, and power. So, but before we round off with the topic, so there is a question. So that was saying by one of our students. So which I will quickly solve the question here right now before I round off with the work, energy, and power that we are dealing with. Now the question is under electric current. So a supply of 400 voltage is connected across capacitors. It's connected across capacitors of 3 microfarad and 6 microfarad in series. Calculate the charge. Of 400 voltage. A supply of 400 voltage is connected across capacitors of 3 microfarad and 6 microfarad in series. Calculate the charge. So we are expected to calculate the charge. So the diagrammatic representation of this should be the diagrammatic representation of this should be. So a supply of 400 is connected across capacitors, of 3 microfarad. This means is 3 microfarad. So and 6 microfarad. 6 microfarad. So and here is the voltage. So 400 voltage. Now calculate the charge. So and we know under the point, so we say 1/C will be because it said the supply of 400 voltage is connected across capacitors of 3 microfarad and 6 microfarad in series. So far they are in series. This will be 1/C is equal to 1/C plus 1/C plus 1/C. So in series. Now 1/C plus 1/C is series, and the number given, parameter given to us in series are 3 microfarad and 6 microfarad. Now this will be equal to 1/C will be equal to 1/3 plus 1/6. So 1/3 so plus 1/6. Now this will be equal to, we find the SM number of 1/10 and 1/6, and this will be 18. So 318 will give us 6. 6 times 1 will give us 6. 6 in 18 will give us 3. 3 times 1 will give us 3. This will be 6 plus 3 all over 18. 6 plus 3 will give us will be equal to 9 all over 18. Now this will be 9 here 1, 9 18, 2, 1/2. Now we have 1/C is equal to 1/2. So 1/C is equal to 1/2. So we cross multiply. When we cross multiply, then this thing we multiply this, then 1 will multiply 2. Then it's 6 plus 1 times 1 will give us is equal to 1 times 2 equal to 2. Now, so it doesn't end there. So our C current is equal to 2. Therefore, remember that remember the formula V is equal to Q all over C. V is equal to Q all over C. Now we make Q the subject of the formula. And when we make Q the subject of the formula, then Q will be equal to VC. Q will be equal to VC. Our V is voltage. Now Q is not VC. Now Q will now be equal to our V. Sorry, we make this one with CB. Q is equal with CB. Our C is equal to 2. So microfarad. Don't forget that this our 2 is in microfarad, and 2 microfarad is equal to 2 so times 10 raised to the power minus 6. 2 microfarad is equal to 2 times 10 raised to the power minus 6, and that is our C. So C times our voltage, which is 400. So our voltage is 400 as given. So in the question, therefore, if you convert this 400 back to standard form, this will give us 2 times 10 raised to the power minus 6 times 4 times 10 raised to the power 2. 2 times 10 to the power minus 6 times 4 times 10 raised to the power 2. Now, applying the law of unity here now, this will be equal to 2 times 10. 2 times, we can correct that time. 2 times 4. 2 times 4 times 10. Because of the same bit, we say times 10 raised to the power minus 6 plus 2. 2 times 4 times 10 raised to the power minus 6 plus 2. And this will give us, this will be equal to 2 times 4, 8 times 10 raised to the power minus 4. So that is our correct answer. So that is the correct solution to the question given by that particular student. By that particular student. Now, solving this, we can now continue with our work. So, we can continue with our work. The work, energy, and power. We have to look into some solutions, some exercises. Then we learn this off. So we have to round it off. So let's continue with the exercise under the work, energy, and power. So we can round off with work, energy, and power. Then we want to heat energy. Nowadays, a sledge is food. A sledge is food 10 meters by a force of 40 Newton. What is the work done? What is the work done? So what is the work done? So a sledge is put 10 meters so by a force of 40 Newton. This is a direct question, and that needed is direct solution. So without any problem, it's put 10 meters. This distance 10 meters. The 40 Newton that is the force. So F is equal to 10 meters. So F is equal to 40 Newton. Remember that work done is equal to 4 times distance. So this is equal to 10 times 40. So this is the force, which will give us 400 joule. So that is a direct question. A slide is pulled 10 meters by a force of 40 newtons. What is the work done? So the slide is pulled 10 meters. The distance pulled by the slide is 10 meters, which is our S. Now, by a force of 40 newtons, and our force here is 40 newtons. Now, it's how we should find the work done. And we know that work done is going to 4 times distance. Now, our distance is 10 meters, our force is 40 newtons. So join them together. So we find our, so we get our correct answer. Now let's look into another little complex question. So let's look into it. An object of mass 50 kg is placed in an inclined plane. At 30 degrees. So an object of mass 50 kg is placed in an inclined plane at 30 degrees to the horizontal. To the horizontal. So the height of the inclined plane is 500 centimeters. It's 500 centimeters. So what work done in moving the object down the plane. Moving the object down the plane. Now we are going to take G to be equal to 10 meters per second squared. So, acceleration of gravity. Now let's look at the question. An object of mass 50 kg is placed in an inclined plane. So in an inclined plane at 30 degrees to the horizontal. The height of the inclined plane is 500 centimeters. The height of the inclined plane is 500 centimeters. What work done moving the object down the plane? So we are going to find the work done. But let's first draw the diagrammatic representation of this question. An object of mass 50 kg is placed on an inclined plane at 30 degrees north. So inclined plane at 30 degrees. This plane will be at 30 degrees. Now, an object of mass, the object is this. The object is this, which is 50 kg. So 50 kg. Now, another mass 50 kg is placed in an inclined plane. It's placed in an inclined plane at 30 degrees, and it's placed at 30 degrees to the horizontal. The height of the inclined plane is 500 centimeters. The height of the inclined plane. That is from this angle to this, the height of the inclined plane is 500 centimeters. Now we have to convert this 500 centimeters back to meters. And when you convert this, we are going to get 5 meters. So that is 5 meters. So what work done in moving the object down the plane? Now, if the angle is 30 degrees, the load is 50 kg, and so the length of the plane is 500 centimeters, which is 5 meters. So what is the work done? From here to here, So is the length of the inclined plane, which is the 5 meter or the 500 centimeter. Now, if the length is the whole length from here down here is 500 centimeter, 5 meter, the half of the length will be 250 centimeter, which is equal to 2.5 meter. So the length, the half length of the inclined plane is 250 centimeter, which is 2.5 meter. So 250 centimeter and 2.5. So it's 2.5 meter. That is the half the length of the inclined plane. Now let's try to draw out the parameter given. The mass is equal to 50 kg. So that is the mass. So our theta, the angle is 30 degrees. That is theta given. The height, so is 250 centimeter or 2.5. The height is 250 centimeter. The length is 500. So 250 centimeter, which is 2.5 meter. Now the length is equal to 500 centimeter, which is equal to 5 meter. Now that is the parameter. So that is parameter. Now force is equal to, remember, force is equal to mg sin theta. To find the force, remember that we have to find the work done. And work done is 4 times distance. That is the work done. But now, here now, we were not giving force in the question. And that's why we were not giving force in the question. We have to find force first. When we find force, then we can now move ahead. So to find the work done by the plane. Now, and to find the force now, we need to use mg sin theta. In the question, we have mass, we have acceleration due to gravity, and we have our sin theta. Now, having all this now, we can get our force. And if we can get our force, then it will be easy for us to get our work done. Now, so let's move on. So our mg sin theta, our mass is equal to 50. Force is equal to m is equal to 50 times g. G is 10 acceleration due to gravity times sin theta. Our sin theta is 30 sin 30 degrees. Now sin 30 degrees, 50 times 10, this will give us 500 times sin theta. Our sin theta is 0.5. So sin theta is 0.30, sorry. Sin 30 is 0.5. Now, so our sin 30 is 0.5. Therefore, 500 times 0.5, so it's equal to 250 Newton. Here is our force. So here is our force. Now our force is 250 Newton. And if that's how we get our force, then we can get our work done. So work done is equal to 4 times distance. Now, the distance now is equal to the length. So the length of the inclined plane. Now, and the length is equal to 5 meters. Our force is 250 Newton now, and our length is 5 meters. So getting the force and the length now, we can get our final. We can say work done is equal to force times distance, which is equal to our force is equal to 250 times our distance, which is 5 meters. So now 250 times 5 now will give us 1,250 Newton. Here is our work done by the inclined plane. So work done by the inclined plane, 1,250. So I can re-explain the solution. So I can explain the solution. The question says that an object of mass 50 kg so is placed in an inclined plane at 30 degrees. So an object of mass 50 kg. This is the explanation. An object of mass 50 kg is placed in an inclined plane of 30 degrees. So this way is the incline so 30 degrees to the horizontal. To the horizontal. Now the height of the inclined plane is 250 centimeters. The height of the inclined plane is 250 centimeters height. So it's 250 centimeters. And its length is 500 centimeters. The height of the inclined plane is 250 centimeters. The length of the inclined plane is so 500 centimeters. The 500 centimeters is what we convert back to meter to see 5 meters. So the height is 250 centimeters. Height of the inclined plane is 250 centimeters. The length of the inclined plane is 500 centimeters, which is now 5 meters and 2.5 meters respectively in meter. So that was how we arrived at this. But remember that to find the work done, this is how we should find the work done. What work done in moving the object down the plane? What work done in moving this object down this plane? And remember that our work done is equal to force times distance. Force times distance. So that is what. But in the question now, force is not given. In that force is not given, we have to find force first. When we find force, then it will be very easy for us to find the work done. We have mass, we have theta, we have length and height. Now, and to find force, we use mg sin theta, mass and acceleration due to gravity. Acceleration is given to us in the question, which is 10 meters per second squared. Now, we have sin theta, we have acceleration due to gravity, we have mass. Having this now, we can get our force. We can get our force. And when we get our force, it is very easy for us to get our work done. So the distance is the length, which has been given to us already. Now, what we need is the force, so we can work out the work done by the to put the object down the inclined plane. The force now is of 50 times 10. 50 is the mass, 10 is the acceleration due to gravity, and the 30 the angle. So times 30. So 50 times 10 gives us 500. Times 30 is 0.5. 500 times 0.5. That is what gives us 250 Newton. Now we are getting the force. And when we got the force, so to find the work will be very easy. What is 250 Newton now? Our distance is 5 meters. That is the length of the inclined plane. So 5 meters. Now our work done is what force, and the length the object will pass. The length of the object to reach to push the object down the inclined plane, which is 5 meters. So the work is done 4 times distance. Our force now is 250 Newton times our distance, which is what? 5 meters. 250 times 5 meters will give us 1,250 Newton, which is our final work done. So that is that about that. So let us look into one more example to round up this topic. So let's look into one example to round up this topic. So let's look into one more example to round up this topic. Now, there's a question here that calculate the potential energy of Candidam if the height is 200 centimeters. If the height is 200 and the mass of the water and the mass of the water is 5 kg. It's 5 kg. So we should take as I draw under the graph, take G to be equal to 10 meter per second square. So let's look into this solution together. Now, what we have to find here is the potential energy. We are asked to find potential. So, and the acceleration of gravity is 10 meters per second square. Now, mass, our mass M is equal to 5 kg. We have our acceleration to gravity as 10 meters per second square, and the height to be 200 meters. The height to be 200 meters. Now, do not forget that potential energy is equal to mgh. That is potential energy, which is equal to our M is equal to 5 times 10 times 200. 5 times 10 times 200. This will give us 5 times 7 give us 50. So, and 50 times 200 will give us 50 times 200 will give us 10,000. So this is about 10,000 joule. So that will give us 10,000 joule. So with that, we're done with work energy and power as a topic. So in our next class, we'll be moving into heat energy. So we're moving to heat energy. Now, so because of the class, I'm so sorry for the class for the being too noisy. So our next class will be like this. So it was due to one form of activity that is happening at the background. So I'm so sorry for it. So do not forget to follow JCSF Support Foundation on YouTube and subscribe to their YouTube video for you to be getting our latest video on our tutorial classes. Once again, I remain my humble self, JS. So the master in charge of this tutorial class on JCSF. So we stop the class there today, then we continue next week. Thank you. Have a wonderful day ahead.